Hey, this is Steven from LegitTechTutorials, and today I'm going to introduce a new season, I guess you could call it, on LegitTechTutorials, and this one is in the product development series, or product design series. So this is the first video of this particular season. I think I'm on season like 5 or 6 different products on this video on developing tech stuff, doing 3D modeling and stuff. This one's more about what I originally envisioned the channel to be about, doing stuff like actual, electronics with, mechatronics type stuff. I mean, not really mechatronics, it's just all electronics. Interfacing electronics with hardware. More of a actual tech project than most of my other things. So this one is a smart battery charger. So me and my dad are into the RC plane hobby, and the RC plane hobby has some varying types of chargers. So what I'm talking about is a smart lipo charger for electric RC planes or other things like that. So other electronics that use lipos or whatever, but mainly RC planes and stuff. So it's definitely a big hobby, and it's got a pretty wide span. So I've been in it for a little while, and I have a few RC planes, a few RC drones, no boats. No, my brother has a car. He's got a Traxxas. He's also in the hobby, but he doesn't like planes. He likes the cars. I enjoy the planes more than the cars. I do like the cars still, so I like everything in the RC hobby. But the thing that lacks are the RC, the smart batteries, the smart chargers. So they do have quite a few smart chargers, but the point that you have to go to in order to get like the really desired functionality, like the very useful functionality. I mean, how this charger is going to be designed is it's going to be way over the top of what you need, but it will also help you become a smarter consumer. So this will also help with a YouTube channel that I plan on creating, where I review batteries from different manufacturers. So this will have basically feature fever, or it just has, I can't remember what the actual term is used. But it will have so many feature creep. It'll have so many features that won't all be necessary. But I'm looking at something that has the features of a $200 to $300 lipo charger, and we'll go over that in a second of what I want it to do. All right, so smart battery charger. We're gonna have it be, like I said, electronics kit, where you have. And eventually this one I want to be my first project that I ever develop a board for, a custom PCB with all these sockets and stuff in it for creating something on it, which would be really cool. Alright, so let's talk about the features of this smart battery charger. Alright, number one feature, this is going to be using. So I'll talk here, this will be the parts that are involved, and here's the features. So the number one feature is I would like to have a TFT touchscreen, TFT full color touchscreen. Okay, so first of all, TFT full color touchscreen, use an Arduino Mega. So Arduino Mega powered, which I have Arduino Megas and TFT touchscreens. Then Arduino Mega, TFT full color touchscreen. Then I want it to be able to obviously charge from, right now I'm thinking up to 6S, but it would be nice to have 6S to 12S. So basically 1 to 6S, and then possibly also 1 to like 12S. So if you're not familiar with what the S stands for, that means cells, and each cell in a standard lipo battery pack can charge up to 4.2 volts, but is 3.7 nominal. So you do 4.2 times 6 is 25.2, right? So 25.2 volts, right? So that's basically how you get the different volt packs. So normally we have 11, normally it's 1S 3.7, 2S 7.4, 3S 11.8 or something, 4S is 14.8, etc., on and on and on and on. And basically what this comes down to is I'll talk about how it's going to be able to support those different batteries in a second. So charge up to 1 to 6S possible lipos, and then multi chemistry support. So basically be able to support multiple different types of batteries. LiHV, lithium ion, lipo, nickel cad, nickel metal hydride, stuff like that. Some other ones that I can't remember right now. So multi-chemistry port, be able to support almost any battery, any rechargeable battery, and also maybe even alkalines, maybe even some rechargeable alkalines. Multi-chemistry support. Then we have temperature monitoring. So be able to monitor the temperature, and then to be able to output charge data in graph. So be able to graph on that TFT touchscreen. So this TFT touchscreen is going to be anywhere between a 2.8 to something like a 7-inch. So hopefully end up at like a 7-inch. So output charge data in graph, and another thing I would like it to have is a be able to schedule charge days. So basically what I mean by that is that me and my dad, we normally go fly on Sunday mornings. So what you would do is you would plug in all your lipos into like a balance board, which also balance board support. So you would plug in all your batteries into a balance board, and then it will be able to, once it gets to the day that you fly, you tell it, I want to fly Sundays at 8 o'clock, right? 8 o'clock in the morning, 8 a.m. or 7:30. Well, for me it's like 7:30. Anyways, to be able to tell it at 7:30, I want my batteries charged and ready to go. So throughout the entire week, it's not charged until it gets to that time. Then it charges, and then you take it out and fly. But if you don't go out and fly, let's say you're on vacation or whatever, which of course you don't want to be on vacation, have your batteries plugged in, obviously. But let's just say that you missed that week and you still haven't plugged in. What it will do is it will discharge those batteries safely, because they're already been charged, because they don't know whether you're going to go or not. They've already been charged, and then it will discharge it back to, I believe, 3.8 volts is a storage voltage. So it'll discharge it all the way back down to 3.8, and then store, quote unquote, store them till next week, and then it will charge it again and wait to see if you go. If you don't go again, it'll discharge it back to storage. So to be able to discharge, storage charge, and then from that be able to do benchmarks. So to be able to charge and discharge a battery. So for example, if I want to see like how good, I want to spend $40 or whatever on a 4S battery, for example, like the ones I use quite a bit, like the Venoms. So be able to plug in a 4S Venom and then have it charge it all the way and then discharge it using either a heater or a cooler, like a heater band or like a cooler, to be able to discharge it under high amperage, and then be able to track the change in the voltage sag, the change in internal resistance, the output current, and stuff like that, to be able to compare batteries side by side. So to be able to benchmark, and also to break in, benchmark and break in. So usually when you break in a battery, some of the more expensive, like $200 to $300 chargers, you'll plug in your battery and it will charge and discharge it. Generally, most people do 3 times. And then at 3 times, your battery is pretty well broken in, and then you could receive, full power. So that way you don't have to fly your planes under lower power, because some planes, not necessarily cars, but some planes can't even get enough lift. When the battery is newer, you have issues with it flying because you can't give it full power. You're scared of breaking your new investment in the battery. So you fly with lesser power, and then you could cause issues with crashing or anything like that. So you want to be able to fly your batteries under full power. So to be able to break in those batteries perfectly under controlled conditions, because in a plane you're not controlled at your discharge rate and whatever, so you don't want to have them balloon or anything like that. So to be able to break them in 3 times to where they're pretty well broken in and they're pretty resilient now to taking higher loads, then that would be nice. And then also to be able to benchmark it while it's breaking in. Okay, another thing is an NFC. So being able to have an NFC card on it, and then you'd be able to take your battery that you're interested in, put an NFC tag on it, and then every single time you charge it, you could check it in and check it out. So basically, whenever it would basically remember every single charge and discharge of that battery for its entire lifetime. So at the end of the life of the battery, you could look back and compare it to all other different manufacturers and different milliamp size and different S numbers, to be able to compare them apples to apples to see, hey, these let's just say, oh hey, these E-flights aren't really as good as these Venoms or these Nanotechs or these Turnigy's or something like that. So to be able to compare them side by side and know, hey, this is a good battery for the money, hey, this one I shouldn't buy again, And to be able, I don't know of any charger that has that capability. Then again, I haven't really looked that greatly. I've looked at some of the RC stores nearby. I've looked at the chargers they had, and this is like the best feature that I've seen them have. Another feature is, of course, being able to write to a thumb drive. So that would be output data to SD card, or to SD card or SD card reader, so you could open it up on your computer and see what's going on. So be able to output all the data of all your batteries to an SD card, so you could go and analyze the data on your computer, plot it in Excel, or do whatever. So if you don't want to mess around with it on the touchscreen, you could do it on the SD card. Eventually, I would also like it to get rid of the touchscreen, the final version, and to have Wi-Fi and Bluetooth. So you could use your phone, which is generally bigger. Well, it's not going to be bigger than, generally most phones are bigger than 7-inch, but to be able to use a tablet or something like that that has internet access and stuff like that, and also this be plugged into your home network to be able to download updates, or to periodically download updates for itself, etc., etc. Discharge, storage charge, NFC capability of tracking lifetimes of batteries, output data, and then also, of course, battery diagnostics, and of course, be able to basic stuff, charge / discharge / balance. So, basic, it needs to be able to do at least the basic charge, discharge, and balance routines. Alright, that's pretty much all I could think of as of right now. So this is temperature monitoring of the battery. Schedule charge days, ballast board support, discharge and storage charge, benchmark and break-in batteries, NFC capability to track lifetimes of batteries. So right there, you know when a battery's bad. Of course, generally when you're flying, you know what the battery is like when it was new, and then you definitely usually know when it's dead, because it just doesn't last as long, not as much power, blah blah blah, and that. But the main issue is like you fly it, you know, the first few times, and then the fourth time, the first 3 times, the fourth time it's like bad. Then you know that then you could go in here and say, hey, you know, what's the issue going on here? Okay, parts. So, a few parts. You're going to need the Arduino Mega. So this is, of course, for the prototype, which I probably should have wrote. Arduino Mega, TFT, full color, touch screen. Then we have a power supply, which is the AC to DC part. And then we'll have a DC to DC step up, or like boost converter, which is constant current or constant voltage. Constant current / constant voltage, and adjustable. So these DC boost converters, constant current or constant voltage, so that way we could adjust what voltage we're putting to our batteries and also what current we're putting to our batteries. Because of course most batteries have a C charge rating, so to be able to type in there that, hey, I have a 2200 and I have a 2200 milliamp hour and it has a charge rating of 5C, like the standard Venoms have a maximum charge of 5C. You know, do 2.5 C, do half the C rating, do 1 amp, 2 amp, 3 amp, 4 amp, etc. And then to be able to also adjust the voltage, and to be able to boost up the voltage in case your power supply is lower or whatever. You know, if it's, for example, the power supply I'm going to use for this prototype I have already, and it's being used in another charger. It's being like attached to another charger. So to be able to just take that off, it is a 14 volt and 10 amp. So 140 watt power supply. So be able to plug that in there and be able to charge, you know, 5S or something like that, and then it would be able to do that at lower amps than 10, obviously. And then we're going to need a digital pots. Digital Arduino pots. So, you know, a digital potentiometer, so that can be controlled by a microcontroller. So a digital potentiometer that an Arduino can control rather than you having to turn it, so it can do it all by itself. So digital Arduino pots. We're going to need current sensors to be able to monitor what current we're putting out. So 30 amp current sensor, and then 25 volt sensor, or voltage sensor. So to be able to read the current and the voltage of your output, and then being able to adjust it with the Arduino pots. Then we need a RTC, real-time clock. Generally, the Arduino Mega has a SD writer. I mean, the TFT has a SD card writer. So you could save images on there. So generally, those have those on there. Okay, real-time clock. Then we need like an NFC reader / writer. Then we need, so these are of course for all the features, right? Then we need, what else? Oh, some sort of load or benchmark. Then we need a thermo resistor / thermocouple. And then all the parts needed for that to be able to put on the batteries and read. But what I was thinking about this one is this one be used inside like a bat box or the bat safe, you know, some sort of maybe even a home built, like just a toolbox for charging lipos safely, etc. Thermal resistor, thermocouple, you know, balance board obviously. And then Wi-Fi / Bluetooth breakout. Even though probably in the final version I'll have a Wi-Fi and Bluetooth microcontroller, and then use the AVR and the Mega just to pull data from those from all those pieces. Also, another feature here is the balance. So the balance charging in most, or the balancing on most smart chargers is it actually just drains the high cell, but this one is actually going to charge the low cell. So each, basically how this Mega is going to be able to track every cell to make sure that the cells are correct and then balance them, it will basically those each of those cells will be attached to the one of the analog in pins. And the analog in pin can read up to 5 volts. So after it's charged, you could switch that out to you could switch that in to an out and then charge it using the max pin amperage, which is 50 milliamp. So hopefully your batteries are very relatively charged pretty close, but if you have the schedule, you could have it start charging the night before, so it has almost the whole quite a few hours to charge it all the way, right? Because 50 milliamp, you know, I did some calculations, and like just if the batteries are the cells are off just by a little bit, it'd take easy 2 hours to charge up the low cell. So basically what that means is your battery will always be at 100%, not like most chargers where you have it and it's like, you know, 95% or 97% because it discharged the high one, right? Wi-Fi Bluetooth breakout, balance board, getting up there on time, 22 minutes. AC to DC, DC to DC, Arduino pods, 30 amp current sensor, 25 real-time clock, NFC reader writer, a load, so like a heater or a cooler, thermal resistor, balance board, Wi-Fi Bluetooth breakout. Alright, that is basically it from what I'm thinking of right now. Real-time clock for that. Yeah, okay. So now I'm going to go over, I just purchased the parts for the basic prototype, maybe like 10 minutes ago, no, more than that. I mean, obviously before the start of the video, so it was probably 30 minutes ago. I bought the parts for this little project because I also need some new chargers. The chargers I have downstairs are starting to fail, so build my own little smart charger. And these pieces, let's go ahead and get started. So I already have the Mega, I already have the TFT touchscreen, I already have the power supply. This one's a 3.2, by the way, this is the one I have. I don't have a 5 or a 7 inch. So I already have Mega, this one, and then I have the DC. I do not have the DC, I don't have anything else here. Right. I might have a load for a benchmark, but or one of these. But I want to use a thermal resistor instead. I don't have any of these down from here down. So what I did is I bought the basic things to turn it into a charger right now. We're going to start with just charging, just smart charging safely, and then we'll work on adding functionality to it. So what I bought is the DC to DC boost converter, the digital Arduino pots, the 30 amp current sensor, and the 25 volt voltage sensor. So let's go ahead and take a look at the main piece, which is the Zinni DC to DC 1200 watt 20 amp DC converter boost step up power supply module. In is 10 to 60 volt, out is 12 to 83, boost adjustable, constant voltage, constant current board charging module. So basically it has this really nice board. It has a big heatsink. The reason why I went with this particular one is how dedicated the company is to putting out, like, they stand, to me, this could be wrong, but it looks like they stand by their product, because they will come in here and tell you exactly what is being used on the board. I don't think any other one on Amazon to get quickly here is telling you exactly what is using on the board. Because at the end of the day, what I would like to do on a final product is be able to reverse engineer these pieces to put it on a single board. So it's really nice to know what they are using so I could build my own later on. So that's also very helpful. And then here it tells you the size of the heatsink, and then what size of fan you need, mounting holes, it tells you exactly what's on there. So that's pretty gnarly, and also has a very nice little data sheet here. So step up module boost, input voltage 10 to 60 volt, input current 20 amp. Output voltage 12 to 80, continuously adjustable, which is what we want. Output current 20 amp max, more than 12, please enhance heat dissipation, blah blah blah. Constant range. There you go, there's the constant range. Hopefully that's continuously adjustable, just like this one probably is. Up to 95% efficiency, and input and output current pressure related. Over current protection, yes, will reduce flow adjustment, adjustable output current limit. Current exceed the current limit, the output current is automatically reduced to a minimum 5 amp. Vary according to the nature of the load current will be. Yes, input 30 amp fuse, double short circuit protection. Inverse to blah blah. Output counter filling, yes, for charging plus blocking diodes is not required, so can't backfill through your battery. Blah, 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 da, da, da. So yeah, max of 1200 watts, but amped at 20, so you can only do 20 input, and then it's probably fused again for 20 output. So the main thing for this one that we are interested in is the potentiometers. So if you see here, let me do a vertical view, or above the top view, we have a few pieces that we are looking for. Number one is we're looking for a board that has the potentiometers, which are these here. These are, of course, are little manual potentiometers. These little manual potentiometers, and this one I think is for like a voltage offset adjustment or whatever. And then here's our constant current amp adjustment, and then here's our constant voltage adjustment. So what we're going to do is you get this, which is a good question, can I even get to that? I'm going to have to undo this piece. But what I'm going to need to do is when we get this board, I need to unsolder these two potentiometers and put in our digital potentiometers to be able to control the board using our Arduino. Another thing, because what a lot of people will do is they'll make their own power supply using this guy. So they'll take this off, and then they'll solder a spin potentiometer that you could use with like your fingers, and then put that on the front panel, and then that panel would have wires that extend all the way over here and grab into that. That's basically what we're doing, except for we're using a digital potentiometer instead of a analog, instead of you physically turning it. Alright, so we get this board in, we unsolder these two pieces here, and then put our own potentiometer in there. That being said, so this was 20 bucks. Altogether, it's about $40 worth of electronics, with this, being obviously very high wattage. Next one is, let's talk about the digital potentiometer. So this is a X9C104, 40 to 100K kilo ohm, 100K ohm. Total resistance 100K ohm, so anywhere between there, between a fine adjustment and the big adjustment. So each of those potentiometers, I'll have to check to see the range that they go, and then be able to write in the program that it bounces from the low to the high, and then anywhere in there is your control. So I bought 2 of these, so that's $5 plus $2 shipping, and it's got quite a few pins here, so we're going to use quite a few digital pins on this one. So again, these are X9C104s. Then we have our voltage sensor. Some really simple, really nice voltage sensor. Has the, I'm wondering if these are this might be analog. It's probably analog. It just has 1 pin. So it's going to use an analog pin, but that's fine. So yeah, maximum voltage range is 25 volt. So you can put 25 volt through the VCC and the ground. So basically the voltage will come through off of this off of this, come through and hook into this guy, and then come out of the ground, and then go to this next guy, which is the 30 amp range current sensor. So from 0 to 30 amp, and be able to tell you, I believe this one might also be an analog. This just got 1 out pin, so it's probably just analog. Anyways, yeah, so 30 amp range current sensor. Alright, that's basically all the electronics I have for right now. So to be able to charge at least 1 battery, and then be able to establish it to you know, multiple balance ports and stuff like that. Another thing about this that I want to talk about really quickly, another reason why I like this quite a bit, is the how it has 2 sets of ins. So to be able to have this as, you know, output to your battery. So the other thing that would have been nice is if it had dual output. But so what you would have is you'd have your battery in here, and then also we could have that relayed, the whole thing relayed, so that when you flip a switch on the Arduino, you tell it to, you know, go high and close the circuit. This would go to like a load, and then you would flip a switch. Then you would have the battery coming in here, and then have your battery going in here, and then this close also with a relay. So now what happens is you are powering a load, and you have adjustable current, adjustable voltage on a load source. Right? So you'd be able to put 12 volts and however many amps this guy is fused to through that load source, and yeah, so be able to test or benchmark with this guy here by using the same board to charge and discharge for the benchmark. Alright, that is pretty much it. Again, this is about $40 worth of stuff for this smart charger, right? So at this point, not really anything, you know. Of course, generally the lowest that I've found for a touchscreen charger has been like 60. It's been like $60. It's around $60 to $70. So already we're below. And I also have another thing that I have is I have a crap load of relays. So be able to put some relays on these guys because I already have those as well. So those are also parts that we're going to need here. Relay, mechanical relay. Because we're doing DC, so we can't do SSR relays. So yeah, I already have the relays and everything. So now we basically built, at the end of this, we built a touchscreen charger for $40 instead of you know, $60, $70. All right, so what will be next is these guys are actually scheduled to come in on Thursday. This the potentiometer is scheduled to be shipped. It wasn't on Prime, so that's going to be shipped later and get here later. But hopefully what I was planning on doing is doing one of these videos every Friday. So hopefully most of these come in on. Oh, also this is Tuesday, so this is already normally different. It's just that I have time on Tuesdays and Wednesdays before class to do videos, so I'm going to start doing that, but I'll probably be doing other videos instead of this one on these days. So again, doing this like every Friday. This charge board, anything that's basically a prime is going to come quick. This charge board, the amp board, and the volt board is coming in quick. And then this one is the slow one. It'll probably be by the end of the month. So, by the end of the month or the beginning of next month. So by the next video, what we're going to be doing is we're going to be doing some circuit layout and circuit 1, 2, 3D. Wait. What was it? Circuit 1, 2, 3 something. The circuits, the online, the web app for circuits by Autodesk. And then we'll just do that to lay out maybe we'll just lay out the wiring, and then maybe we'll go from there in order, like have it create a shield for us and order like 4 of those, and so we could plug in some stuff for quick assembly or something like that. So go from there, go in circuits 1, 2, 3D, lay out all the wiring, maybe do some programming on there. Do some Arduino programming, and then work our way to doing a physical unit and basically transfer it from the circuits to the physical unit. Should be very quick between the two. Get it to do this basic operation and then expand on that, and then eventually either use circuits or Eagle, which has now been bought out by Autodesk. I'm not sure how I feel about that. I love Autodesk, but we'll see if they support the program very well. I'm not too familiar with. At the end of this video, I'm going to say that I'm not too familiar with circuits in general. So this is actually one of my first big circuit projects. So if I did anything wrong with these hardware pieces, picking it out and you seeing it's glaring, if you have a past in circuits, you know, I'm kind of a noob, so this is kind of like a dev blog to get newbies inspired to just go out there and start building their own stuff. Again, you know, another disclaimer that electronics are very dangerous, so make sure that you're very careful. Yeah, so then move on to Eagle or use circuits to make a actual production board with all of these electronics on it. And then that would be my first ever board that I've developed. Alright, so that is basically it for this video. I will see you guys this Friday. Hopefully things come in Thursday and we'll hit circuits and start wiring it up and figuring out what we're going to do from there. Alright, this has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. Please subscribe for more videos like it in this series and other series as well. I'll see you guys in my next video. Thanks for watching. Take it easy. Peace.